Okay, we're doing mixed exercise 5 from the first year core textbook. So we're looking at straight line graphs. We're on question 12, so it's an exam question. So we can see how many marks each part's worth. And they're all relatively short. Also problem solving, so it's not necessarily going to be a particularly straightforward one. We might have to think a little bit about our method. Okay, so I think 12A is all right. The main thing here is not to get put off by sort of talks about triangles and vertices, because all they ask for to start with is the gradient AB. Okay, or the gradient of AB, and you can see it's only worth 1 mark. So gradient is change in y over change in x. I'm going to do b subtract a. It would work the other way around. So change in y is going to be 2 minus minus 2 all over 7 minus minus 1. So 4 over 8, so a half. Okay, and you would have got exactly the same answer if you'd have done coordinate A minus coordinate B. Okay, so nice start. Calculate the value of K, and ABC is a right angle. Okay, so I think we're going to need to use that for this bit. So I've got AB. Do you know what? I'm not even going to draw it to scale at this stage. I'm just to get the theory there. So if I know that ABC is a right angle, and we have just worked out that the gradient of AB is a half. So obviously, if they're at a right angle, they're perpendicular to each other. So that means that the gradient of BC is minus 2. Okay, so that's just using gradients of perpendicular lines. So the gradient of BC is minus 2. And I know that C is K4 and B is 7, 2. So if I was to work out the gradient of BC, I would do change in y, so 4 minus 2. Oh, sorry, can't see that. I would do change in y, so that would be 4 minus 2 over change in x, so that would be K minus 7. Yep, so K minus 7. And I know that should equal a gradient of minus 2. So that numerator is just going to become 2. I'm going to multiply up by the K minus 7. Okay, and then I'm going to multiply those brackets out, being careful with the minus 2 times minus 7. I'm going to add the 2K over to the left-hand side just to get rid of the negative. I'm going to minus the 2 from the 14 and end up with K is 6. Okay, so it's worth 2 marks. Form an equation of the straight line passing through B and C. Yeah, so I think now we've got K, that's not a problem. So B I was given in the question, that was 7, 2. C, well actually to be honest, I don't really need coordinate C. I'll write it, because I think we might need it for the last bit. And we've already just established that the gradient of BC, it is BC we're doing, isn't it? Yeah, the line passing through B and C. So we've already established that the gradient of this line is minus 2. So yeah, so we don't actually need the coordinates of C, because I'm going to use y minus y1 is m times x minus x1. I've got my gradient, and if I can just use B. So I've got my x coordinate, and I've got my y coordinate. So y minus my y coordinate is my gradient times x minus my x coordinate. So y minus 2. Hang on, am I just finding the equation of the line? So I've got no memory to it. So I'm just finding the equation of the line. Okay. So why am I writing the same thing out again? Let's multiply those brackets out. Okay, so multiplying those brackets out, it's going to give me minus 2x plus 14. They wanted it all equal to 0, did they? Yeah, they want everything on the same side. So let's add the 2x over and minus the 14. Okay, that's the form they wanted it in. And then I think, was it the area? Yes, so calculate the area of triangle ABC. Okay, right. So, well, I've got coordinate A, I think I had originally, didn't I? Yeah, so coordinate A and coordinate B I had. C, we worked out the K was 6, so C is 6, 4. So just do a really rough sketch of that. So -1, -2 can be about there. 7, 2, let's put that about there. And 6, 4 can be about there. But also, but more importantly, so that was A, that was B, and that was C. We've also been told, now hang on, where was the right angle? Right, well, there's the triangle. I'll just double check which was the right angle. Right, so actually the right angle was at B. I was about to draw it at C. So I've already been told that is a right angle. That was given to me there in the question. So if I can get that length there, that's the base of my triangle, and that length there, that's the perpendicular height, and then I can use half base times height. And I can get both of those just through Pythagoras. So distance between 2 points is going to be, so it's going to be 7 minus -1, so 7 plus 1, plus 2 minus -2, so plus 2 all squared. Yeah, so I'm just finding the distance between A and B. So let's stick that into my calculator. So that is going to be 8 squared plus 4 squared, 4 square rooted. So I am guessing from that calculation that the base is 4 root 5. Okay, the height, we can put that in up here. Okay, so the height is, see the distance between those 2 points. So that is going to be the square root of 7 minus 6 squared plus 2 minus 4 all squared. Okay, so what's that going to be? 1 squared plus -2 squared. So that is going to be root 5. Okay, so just move that up so you can see it. Okay, so they're the 2 lengths of my triangle. So the area of that triangle is half times base times height. So the half times the 4 is going to be 2. The root 5 times the root 5 is going to be 5. So the area is going to be 10 square units. Okay, I hope. Let's check that. Yeah, area 10, we got that. Yeah, we got C, we did get K6. And yeah, we got gradient over half. Awesome.